Homicide men are the right hand of God. The people demand swift and merciless justice. Do you think you might be ready for that?
Phelps, Earl, a shooting at the 111 Club.
Half a dozen shooters, sir. Real professionals.
I'm only going to warn you once, gentlemen. Stay out of this.
I'm a middleman. I distribute for the LAPD. Destruction of public property, harassment. Jesus Christ!
You just don't get it, do you?
I think I want him dead.
I know a good place. Pick up a shovel and a pick on the way.
Morning, everybody. Hi, this is Mike. This is Mike Balzer, and this is 3D in Review for the 8th of September, 2017. And what you just saw was the trailer, on May 17th. No, that is a few years back. That was LA Noire. And at the time that it was created, it was kind of groundbreaking, the way that it did facial capture and in the way that it set up the mysteries, as you could see in that trailer. I played it a little bit. I thought it was pretty exciting, but the good news is they're going to be bringing it back for some of the, I think for the PlayStation. I don't know if it'll be available for the Xbox, but more importantly, they're going to create several of the sections of LA Noire in VR, and that will be available in November for the HTC Vive. And obviously there's a little bit of controversy, and we're going to talk about that a little bit later. However, the main theme of our show today is how I took apart the HP mixed reality headset, the ones that Microsoft has been promoting lately. As you know, there's also the Acer that was available for developers. So I decided to take mine apart. Well, maybe not all the way, and I'll explain why a little bit later in the show. As I call it, the autopsy. I guess that's correct, since it has no life. Luckily, at least the first time I took it apart, it still worked. But I have some interesting observations and my own, what would you call it, thoughts on the hardware and where they could go with something new. But let's get into our updates from the past. And the first one I want to talk about is this little baby, which I already pre-ordered. And it appears, if you remember, some time ago, there was a product called TPCAST, and essentially what that would allow you to do with your HTC Vive is basically be wireless, no cords, no cables, no umbilical cord. So with this, you're able to walk around. Now, something that I guess I may have been aware of and ignored, because the fact is that you could literally walk around with just a headset, was the fact that you could, or its limitation as far as space, which is about the equivalent of the room space that you can create. But if you were looking or hoping to create even larger spaces utilizing this product, more than likely that wouldn't be the case unless you mounted your PC or the transmitter that this thing works with up on the ceiling or something. So as you can see here, this is the unit. There's some other illustrations. There's some hands-on when it first came out. It was released to developers, or maybe some lucky order, what do you want to call it, customers on HTC Vive. They obviously went out and sold out very quickly. I was able to get out there as soon as I saw the news, but sadly, if you jump out to the Microsoft store right now, yep, this page is no longer available. So they have actually sold out, or at least the pre-sales have sold out. So if you weren't one of the lucky ones to get one. However, I did, and I will be reviewing it and actually be using it at an event that I think I'll be attending. I'll talk a little bit more about that a little bit later. But yes, sadly, it has already been sold out. And I don't know if they had it anywhere else, but as you can see, it's sold out. The other thing in the news is this little product here, which is called SimLab Soft. I've talked about it. I promoted it in the past. It's a cool little product. I basically use it to bring in SketchUp files and then allow it to bake in lighting and shadows and then export that for VR. And I found that it's been very useful for that. It takes a while, but it seems to work pretty well. And So as you can see here, here is a new feature that just came out in their 8.1 plus some fixes. But the most important feature is the ability now to do 360s within the application. And I've actually been very impressed with their renderer. And here's obviously a 360 done with it. And then I'll actually go to a render that I did. This is the small bathroom, and here you go. And as you can see there, it rendered it in, so I've actually added we're thinking about putting a kind of a closet or a small cabinet off to one side. This is actually a really small bathroom, and the idea was to open it up and change the color of it. And as you can see here, the lighting is pretty good. I went ahead and sealed off all the lighting other than what's coming through the window and the door. And as you can see, it actually works pretty good. Sorry about that pause. I have a very old cat that's probably on his last leg, and I kind of trapped him in back here with me, so I had to let him go. So I apologize for that delay, but moving on to this, as you can see, I'll go back to their little render. It's pretty exceptional. There are some great features in this product, and more importantly, it's very inexpensive. Let's kind of look at they have a light version, which is free. And then here's the pricing of it. So essentially, if you want to buy a perpetual license, it's $199 for the Pro version, $399 for the VR. And they also have a nice little feature, which they call their yearly subscription, only $99 for the Pro and $199. So since I wasn't really sold on it, I decided to go with the annual subscription. And I'm hoping that they'll allow me to upgrade to the VR portion. And there's a reason for that. Now that I seem to like the 360 capability, sadly, the 360 capability is only available in the VR portion of it. So you have to at least go with the annual subscription of $199 or the perpetual version for $299. But it is well worth it. Great little program, imports and exports in a lot of different 3D formats, and would be kind of a hand-to-hand tool with whatever else you're using. Maybe Blender, as you know, is free, but if you're using the paid products, this is a nice adjunct application to go along with it. Highly recommended. And I haven't really played with the VR tools, but you can do a lot with the VR tools without actually having to go in and work with what's, maybe Unity, or what's the other application, Unreal. And if you want to go ahead and use this, there's some neat features with it. And let me bring up my laptop, because I actually have my small bathroom up and running. So I'll go ahead and bring up that screen. There you go. So behind me is the small bathroom. I actually have it set up with the camera. As you can see, I can move around in it. I may actually be positioning the camera, which I probably don't want to do, because I want to show off the 360 feature, because it's really easy. Essentially, over on the left-hand side, you have multiple options. You can do the scene building, and that's how to set up your scene. Like I said, I've been able to import directly from SketchUp, but you can bring in other import functions, which I've done before, directly from Blender, do your baking. Now, I know that Blender has some capabilities of doing baking. It's actually pretty good at it. But I find that there's some other tools in here, especially the SketchUp import, that work pretty well. Plus, I really like the renderer. All right, so let's go back to the 360 area, which is what we were in. If you want to do a 360, it's pretty easy. One, you can render in real time, so you can adjust lighting and so forth. So I'm going to go ahead and prepare for rendering. And then it goes immediately into the 360 mode. And as I said, I messed with the camera a little bit, so that's why it's kind of cockeyed. But there we go. And it's building the lighting. Now, what's funny is that if you see all these kind of like distinct shadowing, that's the frame around the lighting system there, which I'm probably gonna have to tweak a little bit because it doesn't need to be so opaque. Or maybe the shadows are that distinct. I don't think so though. And so I'll have to tweak that. The other thing is I have a new conical type lampshade with a light that I put in, which I kind of based upon what I put in my little VR world. But the nice thing about 360s is that you can create some static images that you can work with in a lot of different viewers. One that comes to mind is the NVIDIA viewer, which only works with 4096 by 2048 or 4096 by 4096 stereo. And right now I could right mouse click and capture this image, or I can do what they call a fix to file, which it will then render. It takes about 30 minutes and then it renders it directly to file. And also they have a multiple 360 mode. And sadly, let me go ahead and stop that. Sadly, when I tried the multiple 360 mode, it didn't seem to work right. So I put in a troubleshooting ticket, and we'll see what comes out of that. But in fact, there may have been already a response. So I don't know what the issue is there, but what I'm assuming the purpose of this is to give you stereo pairing so that you'll have obviously the stereo viewing capability, which gives you a more 3D perspective. So we'll see about that in hopefully a later update, or maybe it's just something that I'm doing wrong. But yeah, I think it's a really nice little application. And let's see, let's bring up my camera here and oops, and disconnect from it. All right, so now let me do this. So there's the scene that I had set up with a backdrop so that when you look through the door, that's what you see. I put a roof on it so it encloses all the light, and then there you can see through the window there, which is semi-transparent. And like I said, you can bake this and then send it out as either an OBJ, a Collada file, or even I can't think of the other file format now, FBX file, into Unreal or other formats. And that's what's really nice. Baking, I really like because then you don't have to set up real lighting. It's all baked in. And without lighting, it makes the performance in a mobile situation much better. Something I learned from Rustlin some time back. Okay, so that's it on the update there. If you don't have it already, go ahead and grab it. It's a free update. And let's move into our first item in 3D technology. And I thought this was really interesting. Now, this is a company called Forensic Architecture, and they're using essentially the creators behind it are a number of architects themselves, and they create a lot of different what do you want to call it, environments based upon certain areas of the world that had some contention. Now let's start with this one. This is how I found out about it. I guess there was a case where some extreme violence, they supposedly killed about 40 students. So they're using it to, let me jump back to it, to provide 3D so that you can actually see the placement of all the vehicles. And sorry about that. Well, today's not a good day. Okay, so the other thing that they did is let's see, where was one of the other ones? Yeah, let's just jump to here and then I'll show them all. So as mentioned, the Torture and Detention Center in Cameroon, they were able to take a lot of information, Google Earth and other information, even interviews from some of the prisoners to determine this detention center. Where else? What was another really important one? The M2 hospital in Aleppo, they were able to reconstruct. This had been bombed several times by pro-Syrian forces, and so they were able to actually identify it and the type of weaponry. Another torture prison that they found in Syria and its shape, and again using interviews. So they not only used existing 3D information, but they also used other information like interviews and sounds to determine the type of plumbing. And I thought it was very, very interesting. Obviously, there's some leaning here to looking at some of the atrocities from war and other areas of the world that we had large masses of people killed or tortured. And basically, this helps bring world attention to it, as well as identifying in court all the situations that occurred. And here, let me jump back to that. So here you go. Here's a list of it. So you can go ahead and look at it yourself, but I thought it was very interesting. All right, let's move into, I have a couple of items now in 3D design, architecture, and engineering. This would be the first one, using reality capture and importance of as-built 3D. I've kind of talked about this myself in some of my own remodeling. Essentially, you use either 3D scanning, LiDAR, in my case using I've already forgotten the structure sensor, using structured lighting. You could use photogrammetry, but essentially allows you to capture imagery and then utilize that imagery to build on or build existing or modify existing platforms or structures, as they're showing here. As here. And in this particular case, as I have found by scanning the area and then building onto it, as they said, they were able to save 50%. Here's an image of showing how to actually create plumbing, as well as, I'm assuming, oh, well, I'd have to read about it. But as you can see, a lot of opportunities here. Here's a museum captured using reality technology and UAVs, which we've talked about in previous shows, to create a full 3D image of a building. One of the things that they talk about, and we've talked about on the show as well, is using Autodesk recap or reality capture. They have a proprietary format. So if you want to know more about it, you can talk. This is engineering.com, and I actually have another article from them. So as they call it, reality capture is becoming very important to get the fundamental foundation and then build upon it as the equipment gets cheaper, more sophisticated, and now with the ability of UAVs to take these cameras above and capture information, 3D information. I think that is going to be very important in the future. All right, so on to the next thing, VR architecture. I thought this was kind of cool. And let's see, do I have a little video for this? I want to say yes. Now we can play it right here. So essentially, as they're going through the video, I can kind of describe it. You download an Android app. So if you've got an Android phone, you can go ahead and utilize this. But you can draw, as I mentioned, on a napkin, your floor plan, and then use your phone to capture the image. And here, let's see what they're doing. And then once you capture the image, it then will extrude it and provide you the walls and so forth, as you can see there. And this is the actual application that they have in the phone itself. And here we go. So here it's capturing the image that was drawn. and then you can identify doors, windows, and then once you have it basically to the dimensions and um, you then can either put it in Dropbox or some other format. And there you, as you can see, selects a, so there you go. So now it was exported as a DWG, brought into AutoCAD, and there you go. There's your outline. So next week I'll actually play with it a little bit and give you my opinion of it. But it's out there. It's free. I don't know if there's a service cost for actually using the cloud services, but looks like a very interesting application. All right, let's move on to the next item. If you've been following us for several years now, I think in 2014, we talked to a professor at Monash University about using 3D fabrication based upon CT scans to capture obviously the three-dimensional information and then 3D printed in color. And what they found is not only were the 3D printed anatomical components, parts realistic, but even in some cases more realistic than when you actually capture it. And I can go through there. There's a brochure that you can obtain that has all of the items that they have available. But at the time, they were just thinking about, when we did the interview, of doing this, and it now looks like they're going a little further than just. Let me see if I can magnify that. There we go. So these are the components or parts that you can buy. So they have a full catalog, and they will print these parts for you. And what, if I remember correctly, what he mentioned, as well as what they tout in their little brochure here, is not only are they realistic, but obviously you don't require cadavers, and there could be some cost savings there. But as you can see, they're extremely realistic. And as one person pointed out, what you can see here that you can actually see in a cadaver is the actual sinus cavities, the ventricle system of the brain, limbic system. So I don't know, you'd have to contact them if you're interested in this, but I don't know what their pricing is. I'm pretty sure it's probably going to be very expensive. But if your laws prohibit or prevent you from doing this, or you just cadavers aren't easy to come by, this might be something to look at. And also the fact is that they're so super realistic, might also be a benefit. Okay, so let's move on to the next item. I kind of like this article, one, because of the struggle, but two, the fact is that, again, we're using 3D fabrication. In this case, basically shop type 3D fabrication to create stethoscopes because I guess they're in great demand and they're limited in the Gaza city. So they're able to use a 3D printer. But what I thought was more notable is the fact that the Israels under the the Israel-Egyptian blockade, a wide range of medical items are banned from entering into Gaza without special coordination. And then also the fact that Israel has banned the use of 3D fabrication. As we know in the past, for some obvious reasons, you could manufacture weapons, which I don't quite disagree with. You need a lot more than that. However, that could be a possibility. But the sad thing is, or the good thing is, they were able to use 3D fabrication to create this very low cost stethoscope. And as the author of this article identified, is as good or better than the $200, $300 items that you can't even get. So I felt that this was kind of important. And I think this is, another great use of 3D fabrication. And here you can see the actual printer here. It looks like a number of the components were 3D fabricated to create this. So ingenuity is always going to win out. I feel for their plight, and I'm, I guess, thankful that we have some, obviously, people who are willing to both probably risk their careers, if not their lives, in order to provide equipment to actually save lives. And so I thought that was pretty good. All right, so on to the next item. Let's see, actually, this is as far as 3D scanning is concerned. If you're in an area that you've seen the Google Street View, they've now modified or changed the camera systems. Not only do they have the cameras for RGB capture, but they now have LiDAR, and here they have two of them. Some people have pointed out that they're actually angled at 45 degrees. If you're familiar with our conversations before, LiDAR works on the principle of essentially time of flight. You send out a signal, you capture it back, and that time allows you to determine depth information. You rotate the laser head so that as it's going out and coming back in, you can do it in incremental periods. And so as you can see here, you have two of them. It's not, there's some controversy, not necessarily controversy, there's some discussion on exactly what they're doing with it. And I would have to agree with one person's point that they're not necessarily capturing the 3D information around them, they're capturing the 3D information around the car itself, which means signs. And here are the actual LiDAR units here. What I found was funny is, not funny, but what did they say the cost, and here's one of the LiDAR images shown, is about $8,000. So they have come down significantly. And here we can actually apply two of them. I remember it was $100,000 to buy a Trimble LiDAR system that we used, or the civil engineers as well as the surveyors used. And it not only was very expensive, and I think even the one we got was used, which was $50,000, $60,000. The software is a little more difficult. It was obviously more difficult to set up. It wasn't large, but you had to bring it on the field. You had to make sure the batteries are charged. You had to make sure it was calibrated. And a lot of that has changed in the last 10 years. And as we discussed before, you can actually build your own for a very reasonable price. But these are off-the-shelf units tied in with the RGB cameras. And what some people are suggesting is that when you capture the 3D information along with it, that provides better accuracy. And then, some people are talking about, well, GPS can do a lot of that. But I think a lot of that's already built into this. And the whole purpose is to give more information for 3D view. And I also think it helps provide more mapping data for their autonomous vehicle systems as well, because then they can compare their own 3D information with reference information and utilize it. Sad thing is, if a sign gets removed or a building gets removed, and this isn't done periodically, that data can be an issue. So it talks about more about the process. I would suggest also looking at the reader comments. A lot of people have a lot of different comments about it, and it's kind of fun to read it. So this is Ars Technica, and the article was written by Ron Amadio, sorry. Okay, so move on to the next item. As I opened up our show today, Rockstar's announced LA Noire, the VR case files for Vive, coming this November. Since this came out, gosh, when did this come out? 2011? It's been some years now. I can't remember, but essentially, not only have they improved the textures, because obviously the computers have improved, they are now porting certain parts of this game in VR, and which will allow you to actually interact with objects in the environment with your handsets and drive using one of your hand controllers. So I'm pretty excited about that. I kind of like the game. It was one of the few games that I purchased. So I am pretty excited about this. Some people are concerned that even though it's only available for the HTC Vive, will it work with Oculus? It all depends on if Oculus blocks it like they did with Google VR when it launched. But if they don't block it, then yes, there's a possibility of using it. However, Rockstar made a comment that all they're saying right now is that it's available only for the Vive. So that will be interesting. So hopefully we don't have any more system wars, but I really like this idea. You know, I don't know why Rockstar would care one way or another if somebody buys a version of this on Steam, either with the Oculus or the HTC Vive. What should it matter unless there's some, you know, backwoods controversy between Rockstar and Oculus for some other game that they were, you know, supposed to support and didn't. Don't know, but I thought this was very interesting, and I'm looking forward to it. Okay, let's look at another item. Oh, I thought this was kind of funny. I've read, actually, this is Stephen Marcos. So I thought this was a, what do you want, a parody, but it may, is it? I don't know. I thought it was the Borowitz report. It may not be. So essentially, I don't know if these actually exist, but if these are 360 channels, I'd have to agree with the title, Worst 360 VR Channels. One of them is Mark Spins Around. What's Mark's deal? Does he have a job? How does he never eat or go to his bathroom? The channel 24/7 is just a dude who loves to spin around in his bedroom, and his name is Mark. I just think that's probably some looped video that just goes back and forth. The dirt cam is burying a VR camera into the dirt. The 360 camera room explores a room filled with cameras identical to the one that allows you to do that, or don't. Monotonous doesn't describe it. It'll make you miss Mark. How funny. A ceiling fan to show a divorce conversation. Where's the bathroom? So that's kind of funny. And exciting psychological trauma of getting dunked on. Oh, well. So obviously, I don't know if these actually exist. There's no links. I just think it's probably somebody's silly way of saying how ridiculous we've gotten on what we're using 360 for. And I guess I kind of have to agree. You know, somebody created one. I don't know his name. Cafefe? Don't know. Okay, on to the next item. That's about it for our news items. So let's get into the main topic of today, and that is my breakdown. So let me bring up my main camera here of the HP mixed reality headset. So let's kind of take a look at this. We've got a couple here. I'm going to bring up some parts. Now, one thing that I've noticed, and this is also, I'm going to put some images against later, is that somebody also did a teardown, and there'll be a link in the show notes. A guy who documented pretty well for the Acer. So I thought, well, they look a lot alike. So are they very similar internally? And the answer to that, which I'll get to a little bit later, is possibly. So here are some of the parts. Lots of plastic. Here's the front visor that Chris mentioned, made me look like Geordi from Star Trek Next Generation. Here's another piece, another frame. Here's another piece that you support the padding as well as the nose piece. Hello. And then let's see what else, if I can bring this up here without dropping everything. You've got this piece, which is the headband, which is actually fairly nice. I kind of like this piece. And it works pretty well. The sad thing is, unlike my own headset, where I had 2 points of articulation, this only has 1. So as far as it lining up properly and supporting your face, that makes it a little difficult. It just drapes down, and then you have to basically adjust the headband. And then what I found is I have to rest mine up on the top part of my head. Some people may have to rest it lower on their ears. So I felt that having an articulation point besides just one hinge would be better. Also, the fact is that you can't tighten this down. It doesn't really fit tightly against your face like it should. I don't know if that will change. Again, like I used, which was the what was it? The GoPro type mount screws. So that way you can tighten it down and keep it in place. So I found that even though you can walk around with this, running, jumping, didn't keep it firmly in place. And so that's a little disappointment. Now, I do know there are other models out there. Some people really like the Asus. The other thing I found out when I took this apart, tons of screws. I know that you can't see them, a lot of little tiny ones. In fact, sadly, I have a feeling mine had been taken apart before and then sent back, or whatever the case may be. I found 2 of the screw heads stripped and had the drill one out, and then I used a Torx head in order to actually pull it out. A little more difficult. And then there was another one, it looks like that it was put in offset or something, and that caused some problems in removing it. So I was a little concerned about the quality perspective. I mean, from a plastic component, they're well made, but I don't think the assembly left a lot to be desired. And then finally, the actual housing. And I've already done some little bit of modifications to it. So this is the actual assembly. This contains the LCD panel, and we're going to go through some of the parts that have been identified and some of the images here in a little bit. But it also includes the main board and obviously the optics. So we're going to talk about the optics, which in this case, as some people have already pointed out, are Fresnel lenses, and we're going to look at that. But I've also did a little modification using my own Neodi Play. What do you want to call them? Eye cups. So that way, instead of having a large piece of plastic, like a goggle, these are more like, what do you want to call it? Blinders for glasses. So if I get another unit, because I don't think I'm going to break this down any further, I will pull it apart, which would only give me the circuit board, the LCD panel, and the optics. Then I'll have to create a 3D piece, print it so that the 2, and I'm pretty sure these are just RGB cameras up here in front, are mounted correctly. I could make this probably about 1/4 of the weight. So make it extremely lightweight, either use my own headband or the existing one. And then what I'm going to do is make this available as a kit that you can download and 3D print yourself or buy, and make this thing much lighter and more compact. And even with this thing here, I was with my own little eye cups just holding up to my face, I found the experience to be a little more immersive because your eyes are closer to the lenses. But I will talk about that a little bit. These are unique lenses, and I found that the immersiveness, unlike some of the other, like the HTC Vive, bringing your eyes closer to the lenses, in this particular case, doesn't necessarily provide you that same immersive experience as you do when you bring yourself closer to the HTC Vive lenses. And I'll explain why in a little bit. Okay, so let's look at, let's see, what do we want to start with? Let's start with some images. And I'm going to mix these along with the images from the Acer. And the reason I'm saying that, let me see if I can find them. Looks like my image are gone. Okay, so let me bring those in. So give me a moment. Okay, so here we go. All right, so I'm going to bring these up. Put myself in the image. There we go. Okay, here we go. Okay, so here are a few images. This is from the Acer itself. Here's your Fresnel lenses. So it essentially has a box. This center, you can't see my cursor, but there is some optics. Essentially, this is what you have both on the HTC Vive and the Oculus itself. This determines proximity so that when you have your face up against it, it enables the panels and basically tells the computer, hey, I'm awake. Go ahead and provide me information. Let's go on to the next one. This is a little blurry, but this is an image of one of the chips that I'm familiar with this symbol, but it doesn't identify with me. I have a feeling, and I'll show you on the larger screen here in a second. And another blurry one. So here's the actual board. Again, this is from the article for the Acer. And what I found is that this board and the optics are almost identical. In fact, they have a same part number. So I feel that all the Microsoft vendors who put this together, meaning Dell, HP, Asus, Lenovo, are all using the subassembly from the same vendor. They're just building a case around it. And that's kind of worked out. Now, what's funny is this version here was made in February. Mine was made in July or June. But again, the part numbers is the same, just a different revision. Actually, I think the revision number was similar as well. So a little bit later, I will go through and identify some of the components that I found. For instance, the LCD panels, who makes them, as far as the chips that allow you to generate imagery, the fact that this thing has 2 co-processors, or ARM processors, I won't call them co-processors. Explain a little bit about that. The fact that it has an audio chip and a few other features, and we'll kind of get into that into a moment. Here's some more. Here's the actual chip, as well as another chip here, and I'll explain what these chips are for. But one of the things that I found is that this thing has a lot of USB 3 components on it, and then HDMI to MIPI converters. And then had a unique, because this thing has 2 cameras, a 2-camera probably multiplex together and then sent out a USB as well. But it has a processor, so I'm wondering if that processor is used to do a little bit of processing of the video information before sending it out as a stream. I do not know that at this particular point. These are some of the driver circuits for the cameras. There's 2 of them on each side, as you can see here, down here, and on this side. And then here's all the parts that I tore apart on the HP headset. And then this is an image that I took of the headset that I opened up. And here's the LCD panel. What I found different with mine is that I have a mirrored background. Also, the part number for the LCD panels is listed here, and I will get to that in a second. But these are sharp, about 2.98 inches diagonally at 1400 by 1400 pixels. But they're very small. They're, for instance, if you're familiar with the Oculus, that's a 3.5, and then with the HTC, it's a 3.6, and then the OSVR headset is a 3.9, if I remember correctly, so it's even larger. Now, the difference is, with all these different sizes, there's kind of a sweet spot, and some people think it's the Oculus, but by having the same resolution, at least on the Oculus HTC Vive and the OSVR system, that then would determine your PPI. And the Oculus would be winning because it has a 3.5. Now, keep in mind, though, that doesn't mean a lot, because you have to, because it's a 3.5 inch, you still have to magnify it. So sometimes the magnification has to be a little bit more, and that would probably be the case with that. And obviously, in this case, because they're even smaller, the magnification is even more significant. Let's see if I've got another image here. Yeah, here's another image, a little blurry from the other direction. So as you can see, the board is almost identical to the one that I showed you from the Acer. In fact, I would say it is identical. Maybe the layout as far as assembly of the cables and so forth, a little different. The information I'm going to be showing you on the Sharp LCD panel is actually a XO2. These are XO4s. I couldn't find anything in my quick search on them. I'm just assuming that they are just another revision of the same panel. So I don't know the exact difference between it. And we'll get into what my theory is. Okay, and then here's an illustration of the block diagram of the hologram. And the reason I'm bringing this up, what makes the hologram unique is not only did it have its own built-in Intel Cherry Trail SoC, which essentially is a full computer on a chip. It's the same thing that was in a lot of those Windows tablets that came out early on. It also has its own HPO, the holographic processor unit, that gets hooked up to a lot of the sensors and takes this sensor information and something else that's not identified here, as well as, let's see, is it here? Yeah. No, it actually isn't. So it takes all the processor information and the depth information and essentially integrates it and processes it and then sends it off to the Intel Cherry Trail SoC. So it provides some of the, what do you want to call it, the muscle behind what needs to be done to process depth and your IMU information. What I did find striking is that the video cameras are sent directly to the Intel through the CS2 type channels that are used by the mixed reality system. So essentially the Cherry Trail was taking care of that information. And we don't know at this time if this also provides positional tracking along with the depth information. But the fact is that these were brought in separately into the chip makes sense. And we'll get into a little bit more. Let's see what else I've got. And here is the part numbers on both the HP and the Acer. Notice the top number is identical. The dates of the two headsets are different. This one was made in June, end of June. This was made in February. And obviously, I'm not familiar with the bottom number here. The revision numbers, this one's a little blurry on mine, revision 2B, revision 2B. So it's the same board. So this is why I believe they're made by the same subassembly vendor and sent out to the major manufacturers, which is not surprising. This has been seen before. That's why a lot of these devices always look so similar, because they use internal subassemblies that are identical. So it's just the outer shell that takes on a different perspective, design flair, depending on the company. Okay, so let's jump back to my regular screen, and we're going to look at the screen. This is a PDF of the specification sheet on the XO2 LCD display. And all these links will be in the show notes so that you can peruse them on your own. But these are the 3.98 panels. And I have some notes, and I'm going to bring those up in a moment here, or actually talk about them in a second. But one of the things that's important to realize and why it appears sharper, one, it's 1400 by 1400. The other is it's a full RGB vertical stripes. Unlike the resolution on the HTC and the Oculus, which uses a pentile OLED screen, this does not do it. It's a completely RGB striped, and it runs at 120 frames. But there's some interesting things that I read about this, is that because it only has, I think it's, how many ports does it say up here? 1 pixel. Okay, so it says here, I think it's 4 channels. Yeah, now I've lost it. Here we go. Well, this will tell you. So it has 4 channels, as you can see there. So 1 through 4, and then 2 ports. And that's common. So essentially you have 4 channels per each screen, and then 2 ports each. However, the bandwidth, which I found later on, would exceed your standard video output. They actually said they were using this for 4K. So they have a way, if you use it with a Toshiba HDMI to MIPI chip, that you have a form of compression. So I'm assuming that we have some form of compression with this as well. But it is capable of actually going all the way up to 120 hertz refresh. But here they show the 60 hertz with no compression, 90 hertz with half compression, and then also 120 hertz with half compression. So I don't know. They're saying that that compresses to an active area of 720. So I'm not familiar with exactly what they're doing there. I don't think that we are actually having the resolution. There's some other tricks probably going on. From what I read in another article, this compression does very little to affect the screen quality. Okay, but all the full specs are there, your clocking and so forth. But again, this is the 02. I'm not quite sure what the 04 version of this is. I could not find any information on it at this time. But the fact is that the measurements are identical, the resolution is identical, and the part number is only off by 2 on the end of the part number here. Clearly identifies it as a Sharp product, and it being an LCD. As far as LCD is concerned, I found that the latency on this was really good. I didn't really notice any blur. The other thing that I noticed was that it was indeed sharp. I felt that the Fresnel lenses that were being used with it left a little bit be desired and made it a little bit softer. I was hoping that they would go to another type of lens, but I think I understand why they did, and I'll get into my measurements and talk about why I feel they went with a Fresnel lens that you don't see in other headsets. It's because, well, basically you want to bring the magnification and the lens as close as possible to the panel, because in this case the panel is so small. If we bring the lens further away with it, away from it, it creates, as I call it, a conical view. And if you bring it away, it spreads. So you start seeing the edges of the panel, which obviously kind of breaks the immersion quality. So you need to bring the lens closer to it, which obviously requires a smaller focal length, and that normally in a standard lens design makes it thicker, but in a Fresnel we can get away with that. The other thing I noticed is that this lens, and I'll go ahead and bring it back up again. Let's see. Where is my screen? Here we go. Is the lenses aren't flat. They have a little bit like the Oculus, a little bit of a curve to them. These are not only Fresnel, but they also have a little bit of curving, just like the Oculus. So they seem to be specially designed for this. I measured it, and let me find my notes. I measured what I'm assuming is the distance from the lens, and normally you want to measure from the physical center of the lens to the panel itself. And since the panel is actually underneath here, it's built into here. So I measured it from here to here, and I came up with a figure around, let's say about 30 to 31 millimeters. Obviously, that all depends on how accurate my calipers are. But that would make it a short focal length. And normally the ones you see in the Google headsets, cardboard, are like 45. And I think we're about 35 to 40 in the HTC Vive as well. Don't quote me on that. I haven't actually pulled one apart. So by making it closer, if you notice the actual, what do you want to call it, frame of the lens boxes, as I call it, it's more of a cylinder. If you look at my own case, I spread mine out so that the lens themselves spread out across the entire panel. This, because they're so small, and also the fact is these lenses are so close to it, they opted to go with cylinders. Now, I have an issue with that because unlike my design, if you bring your face closer, and the HTC Vive would be the same way. If you bring your face closer to the lenses, normally that allows less of the outer edge of the lenses to be seen, giving you a more immersive quality. But in this case, as you bring yourself closer to the lenses, it actually creates, you can start to see that there's a cylinder in there, and it kind of, I don't know if there's some reflections, I don't know what kind of material. Obviously this plastic does have a sheen to it, as you see. I don't know if they coated it. I would have coated it with a flat material, which is what I've done with my own headset, and that prevents some of that. So that may have created some issues with it, but you start to see that it's a cylinder inside. And I found when I backed away a little bit, that kind of went away. However, if you do bring it closer, if you can handle the halo, it's not that strong, it does seem more immersive. Again, that only can happen if you remove the cushion on the inside of this, but that might not be the direction you want to go, because then you have plastic up against your face. But I found that your face doesn't even actually touch it if you don't have any of the cushion. So that's kind of a moot point. And I've actually modified this to create it, to bring it closer, and then just left it the way it was. because it didn't really fit well, because as I talked about earlier, it only has one point of articulation. So my goal with a future version, or maybe this one once I get the next one, is to remove all the plastic, create a separate housing that supports the cameras, but make it much thinner than this, and a separate mount. So literally it'll be about 1/4 the weight. So it'll literally feel like a very small compact glass system, which is my goal, and it's been a goal with my own Neo Play. Excuse me, Neo Play. All right, so the other thing I found out is the lenses themselves are about anywhere between 47.5 to 48 millimeter diameter. I will say more like 47.5 diameter. That makes them larger than most of the mobile headsets. It is slightly smaller than those that you see in the Oculus and the HTC Vive. But again, because it has smaller panels, that makes sense. So it's not that much smaller. What I did find is that they put a ring around it. Let me show you. That fits over the top of it. It doesn't really hold it in, but it kind of provides a ring around the border. So then it actually, if you measured this is more like 44 millimeters inside. So it kind of does away with it, but the actual lenses themselves are a little bit larger than that. Okay, so let's move on to some other information that I have. So how do we get a conversion of HDMI to 4K, excuse me, what they call MIPI information? They run it through this slim port 4K Ultra HD receiver, and here they show it MIPI output 0, 1. So you have your 2 channels there. Notice it only has 2 ports, 1 and 2. And so the goal is to bring in, and actually they call this a display port. It's not truly an HDMI, but some of these can be converted. So this is actually a display port 1.4. So you bring it in. The fact is they didn't go with a Toshiba. Kind of makes me scratch my head a little bit. There's no reason to do that. Obviously they didn't. And let me go back and see if I can find my, let's see. Here we go. So if you look at the board again, the actual chip that does that is down here. Let's see if I can read it. I can't. U1412. That's actually the slim port chip. And here's your actual cable coming in. It provides your USB and your HDMI input to this. Okay, so some of the other chips that I found, let's jump back to it, was a Cypress Semiconductor. And this one is located, it's a USB bridge chip for 4 lanes. This one is actually located, where is this? Up here, I believe. And this provides the USB bridge chip functionality. The chip next to it right here, let's jump back, is an STM32. And this is something that I found in all the different headsets. And that one is located not all the way to the right, right next to the chip on the right, the one that looks like little hands up in the air. That is the audio chip. The one next to it, to its left, is the chip that provides the, I'm sorry, 2 more over. Right next to the USB chip is the STM32. This is a chip that's used in, it appears, all the headsets. So it provides control. More importantly, it provides processing of IMU data before it heads out the USB port. And that's what we see this here, and actually does some other functionality as far as aligning all the data and resetting all the chips. So it's kind of the, what would you call, the master brain. What I did find unique about this, and let's see if I can jump to it. And it was located on DigiKey, so I'll just go ahead and go with them, is this chip here. It was a USB 4-lane chip, and the purpose of this was to allow for, and here's your full see, there's actually a video for it, but you can read it yourself. But it allows you to bring in the two, and I'm assuming they're CS2 based video cameras. These are the same type of cameras that are used in vision capturing uh, for AI systems, robotic systems. And obviously here we need something to not only bring the CSI2 and convert it into a USB 3 stream, but it also has a ARM, was it ARM 9 processor on it with half a gig of memory. So this thing has the capability of doing some processing. So I don't know if it's just used to store the information from the video or they're actually doing some processing on it. I would not be surprised. It is programmable. So they may refine that, maybe multiplex it so that it's palatable to the computer. I don't really know what they're doing in the chip itself. It may just be converting it and then processing it, putting in a friendly USB 3 stream so that it can be sent to the computer for further processing, which means the computer actually is doing all of the processing for you. Or they could be essentially looking at certain, maybe doing a little bit of their own, what do you want to call it, parallax processing through the processor on this and then sending it to it. Don't know. Obviously, we'll find out more later from other people who are working with it. And if I get some more time, I'll do a little bit more research on it. But that information, it's kind of a black box right now from a developer's perspective, or at least that's what I found. Essentially, you send information to it. You don't have a lot of control what's going on internally. So we'll see what happens, how much more information will be available, but it would be intriguing to know how much of the HoloLens, I'll call it effect, was actually put in here. Obviously, the algorithms for parallax camera tracking that they learned from the HoloLens is probably presented here. The fact that they have these very small panels, which interesting, they seem to be illuminating from the back. So I would not be surprised if you're going to see another version, maybe using these sharp LCD panels to create true mixed reality, which means instead of having to look through lenses, they'll be reflected into a visor very similar to HoloLens. I would not be surprised if we do see something like that. Okay, so let's see what else. I talked about the STM. There are some other chips in here, these multiplexer, demultiplexer chips. There's a few of them in here. They're some of the smaller chips. Actually, where did I see them? I think they're up here. And then there's this chip here, which I took a picture of. If you look right above the 4, kind of middle off to the left a little bit, I'm pretty sure this is the IMU. And I think I've seen this symbol before. It's not one of the ones that you're seeing like the Bosch IMU that's used by both the HTC Vive and the Oculus, nor does it seem to be the other, what is it? I can't think of the name now. I want to say Sensic, but that's actually the company who creates the OSVR system. I can't think of it now. And it doesn't appear to be that company. So those are the two big companies. So I'm thinking it's the same company that creates the ST, but the logo on it does not match. So I don't think so. So I'll have to go back and do some more. I tried to do some research last night and couldn't really find anything. So we'll have to go back and address that, but I'm pretty sure that's the IMU, which would not surprise me. It's either this one or actually there's really no other chips that it could be. So there's one other chip that it could be, but I don't think that's the case. I'm pretty sure that this is your IMU. And if it is the IMU, again, I don't know who makes it. And IMUs, especially well-calibrated IMUs, as well as the RGB cameras, are what allow the positional tracking to work so well. And so whatever they're using is probably well-calibrated, very accurate. And again, this information is probably fed into the STM32, which is at the top here in the middle, and that is in process, and then send out the USB 3 multiplex channel or chip that's to its left. And then, like I said, your HDMI to MIPI conversion is done to these two chips, one to the far left in the middle, and then the one right to the next to the side of the connection coming in. It's a smaller chip there. So it's fairly straightforward. A couple of embedded processors, the STM32, and then the Cyrex chip have processors, and then an audio chip, and then some multiplexer chips for USB 3, some driver chips for the video, as well as driver chips, obviously, for the panels themselves. And that pretty much sums up the board. One of the reasons why it's fairly low cost, there's not a lot of components. They're all fit on this. The back of it, let's see if I can jump back to one of my images. Has a few components on it, but nothing. I noticed that there appeared to be a location for another chip. I don't know what the purpose of it is on the back of it here, but it obviously is missing, but it would be a fairly large component. So it'd be interesting what else was thought of or designed in this that hasn't been added. And obviously you see the panels coming in through the back of the board. And then it just essentially mounts to it, as you can see. So it creates a very small, compact system. So actually, let me change. I apologize for that, not switching my cameras. So here's the back of the board. Where's it at? Here's the front of the board. Again, I'll review it. So here is your, let's start and go clockwise, starting at the top. So next to it, this is your USB multiplexer chip, USB 3. Right next to that is the STM32 in the middle on top. Next to that, I don't really remember, it's some type of driver chip. Next to that is the audio chip. Right below that, the larger chip is your, like I said, a Cypress processor, ARM9, and CS2 to USB 3 converter for video chips. Now that's its purpose. I'm pretty sure if we continue, the chip second to the left is the IMU. The one to the complete left is your HDMI, to MIPI, and then also the one right above, next to the connector itself as we go up is also for that purpose. So these are combined to provide that functionality. And so there you go. That's about it. Obviously, there's some peripheral drivers and driver chips else around the board, but altogether, it's a fairly small board, low cost, and as I show here, all contained basically in a very small package. So that's really all that you need in order to drive the screen. The rest of it is just plastic for whatever reason to make it large. I don't know. But there is no reason why they could not have made it a little more thin. In fact, I think the Asus probably has a smaller profile because they did do that. Okay, so that's basically the autopsy of the HP headset. And I also want to thank, let me find, let's see, I actually have it here. Jacques Weiss, who put together this breakdown on his own, what did he use here? Basically his own blog site. Very nice, broke down all the components. He didn't actually go through and analyze the components. Hopefully I provided a little bit more light on it, but these are some good diagrams to start with, especially if you have an Acer. The most important point is that allowed me to confirm that these things are using either identical or very similar subassemblies. Obviously the revision number is going to change as we move along, but yeah, I thought that was pretty cool. Nice little headset. You know, a lot of people complain that actually, I didn't jump back. So here's the website. And this will be in the show notes too. So give him a shout out. So thank you. I hope I'm pronouncing your name correctly, Sacher Weiss or Weiss. But he's only one. iFixit hasn't done a breakdown of this headset yet, of either one. So I thought I would spend a little time doing that. Maybe they will do one and confirm or come up with some new information. So he talks about how he didn't actually remove the cameras. I agree, I wouldn't have either, because what would you do with them once they're removed? But he did remove the board, so there you go. There's the full board. So the board can be removed without while keeping the panel separate, because there's just these two connectors there, which is what he did. He thought it was hermetically sealed. I don't think so. It's not hermetically sealed. In fact, I was able to get some dust in mine, so I can definitely tell you it was not hermetically sealed. In fact, because I think it's somewhat, well, as mentioned, this is mirrored on my end. Also, to confirm that these are 04s, his also shows that the sharp panels also end with 04 and not 02. So again, I don't know the big difference between them. I'm assuming that it's just a better quality, or not necessarily better quality, just a more advanced or just a revised version of it, or maybe specific to just this headset. Unknown at this time. Okay, so let's jump on to my last item, update on my low-cost VR backpack. This has been slow going. The main problem, if you remember my backpack, I actually had the Gigabyte GTX 1050 Ti on top of the headset itself. So even though I used a small case, I had to put the card outside of it. What I wanted to do with the mini case is create or find a case, and it's been difficult. And let's see if we can get some information. Is find a case that supported only a half-height card, but still supported the small setting or the small size of the mini ITX port. So I really wanted an A10, which is a little thinner. It's not that much, maybe about half an inch, maybe 3/4 of an inch. What do I call it? Shorter. But having it at this size really wouldn't matter, which is the A20. They don't make the A10 anymore. And what they did is they provided a little more clearance for the fan and allows it to actually fit a double wide half height card. I found that it will still fit on my baseboard for my backpack. So with that being the case, and the other thing that I found was very interesting about this, not only are they fairly stylish, but these cases are very reasonable. This one you could buy from their US site for only $49.95. I don't know if they have a local distributor. It should be in by the end of next week, I'm hoping. But that'll allow me a little bit of breathing room. More importantly, it will fit what they call a slimline power supply, but I don't want an AC controlled power supply. I want a power supply that you can bring in a voltage that varies. I also have some parameters. I found a circuit board. Let's see if I can, hang on. This circuit board here, which let me jump back to my main screen. And the reason that I chose this particular board is because, one, it handles about 150, 160 watts. And I found with a CPU, or excuse me, a GPU that pushes about 75 watts, and then your motherboard supports about 50 watts, that kind of pushes it into the 110, 120 watts. The other thing is, even though I have a what they call a Pico ATX power supply, which actually fits into the connector itself on the motherboard, it can only be run with a 12-volt power supply. It has to be about 11.5 to 12. Since I was running this with batteries at 14 volts, lithium ions, that basically didn't start. Now this will work, but the sad thing is it will not fit in the case. So it doesn't fit in my smaller case, but it will fit into this A20 case. I'll mount it on the side. I will, it essentially has two cables here. I will mount yeah, I can't think. a coax connector to it, female, so that I can plug in both either the battery or a power supply. I also bought some, what were they, about 10 amp, 10, 15 amp Schottky diodes, so that I can run the power supply as well as the battery together without burning one or the other out. So that way I can plug in the power supply when the battery is about to be depleted. It will not charge it, but that's the nice thing about this. It also has a sensor, so if I get below a certain voltage, it will send a command to shut down the computer. So you'll get a soft shutdown without it actually depleting the battery. And by doing it that way, you can hook up an AC without having to shut down your computer, and then switch out your batteries and then disconnect the AC to keep on going. With this system, with about 160 watts per hour battery, you can get, I'd say, about 45 to an hour. And obviously you could multiple gang these. It's up to you how many you want to add to it. The connectors, let's see, do I have it here? I didn't bring it, but for about $6 to $10, you can get an actual connector for these lithium-ion batteries. There are two different types I talked about. There's an Anton Bauer type, which kind of has like two pins holding it in place. And then there is the Sony V-Lock. Sony V-Lock seemed to be more predominant, at least on Amazon. For about $100, though, you can buy one of those batteries for about 160 watts per hour and be able to drive your little backpack. Now, some people are wondering, can you use the GTX 1050 Ti with HTC Vive? And I'd have to say yes. Now, I didn't run some of the more demanding video games, but I did run it with most of it, and it seemed to run just fine. The fact is that it's overclocked, and you could actually push it a little bit more than that. Also, the fact is I'm only using an i3, but I did find an i5, meaning it has four cores that runs at 35 watts. That is something also to take a look at as well. And that it also provides you a little bit more processing power. So in fact, you can probably get one. The reason I'm a little drifting here is that you can get one on Amazon for about $100. There's a couple of people selling them used. So the whole point of doing this was to create a backpack VR system that was about half the price which you can buy a retail version, and I'm pretty close to that. Like I said, this case is only $50. It's actually $10 cheaper than the one that I'm using now. So great little find there. It's by Geek. Let me jump out to them, give them a shout out. So if you're interested in creating a compact system, again, I'll have this in next week. I don't know if I'll have it in time for next week's show, but if I do, I'll of course bring it out and show some of the advantages of it. The fact that you can also put in a fan for more cooling. But keep in mind, the more items you add on it, the more it's going to consume power. And the goal behind this is to be able to put something on your back and be able to walk around for at least an hour. So anything that you add to this that's going to consume more power is going to deplete that capability. Now, of course, you could put like a car battery on you and have all kinds of hours, but I don't know the last time you've looked at a car battery, but they're not lightweight, and putting that on your belt or on your back, I would not recommend. So with that, we're getting close to it. I'm hoping to be able to show this off next week, if not the week after. So that's about it for this week. So that is 3D in Review for September 8th, 2017. And we'll see you next week. And I don't know yet what I'll be covering. As mentioned, maybe the backpack. Obviously, there are going to be some new things. On Tuesday is going to be the Apple show. So, Apple show. I guess it's going to be at their new symposium. What do they call their place? But obviously, their new location, they're going to be using it in their own theater. That'll be in the morning, I think, either 10 or 9 a.m. on the 12th of September, Tuesday. And they'll be announcing the new iPhone 8, or maybe they'll be calling it the iPhone X or 10, whatever you want to call it, or the anniversary phone. But clearly there's going to be some features in there that will cater to augmented reality. Who knows, there might be some other items mentioned. So I'm looking forward to that. As I've talked about in the previous show, it appears they are using some type of 3D scanner. I don't know if it'll be isolated just for facial scanning. If that's the case, it seems like a waste. of not only resources and money, because it's not cheap to add that kind of capability, but that would be Apple, right? So if they do waste the resources there and you don't have access to the depth camera, then you're just limited to a camera, or the fact is they may be using some form of parallax with the dual cameras on the back. There is that possibility. We'll see. It's all going to be coming up on Tuesday. So I'll be talking about again that on Friday. Maybe they'll have some new neat features that will be available. And as normal, they normally don't have the latest version of iOS or their products available towards the end of the week for order. So you'll have a few days to breathe before that point. Okay, on that note, I'm going to say goodbye. Bye. Have a nice weekend, everyone, and see you next week.